Dear learners of class 12th, today we are going to understand the properties of amines. After this discussion, you will be able to describe the important methods of preparation of amines and explain the physical properties of amines. Amines are prepared by a lot of methods. All the possible methods are listed on the screen. Let us understand each of these methods of preparation in detail one by one. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Thus, only a small amount of hydrochloric acid is required to initiate the reaction. From the previous knowledge, we know that the carbon-hydrogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reaction, in which the halogen atom is replaced by an amino, that is the NH2 group. The process of cleavage of the carbon-halogen bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salt. Ammonolysis has the disadvantage of yielding a mixture of primary, secondary and tertiary amines, and also a quaternary ammonium salt. However, primary amine is obtained as a major product by taking large excess of ammonia. The order of reactivity of halides with amines is Ri greater than Rbr greater than Rcl. Nitriles on reduction with lithium aluminium hydride, that is LiAlH4, or catalytic hydrogenation produce primary amines. This reaction is used for ascent of amine series, that is for preparation of amines containing one carbon atom more than the starting amine. The amides on reduction with lithium aluminium hydride yield amines. Gabriel synthesis is used for the preparation of primary amines. Phthalimide on treatment with ethanolic potassium hydroxide forms potassium salt of phthalimide, which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. Aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by phthalimide. Hoffman developed a method for preparation of primary amines by treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contains one carbon less than that present in the amide. Now let us understand the physical properties of amines. The lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid and still higher ones are solid. Aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. Lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. However, solubility decreases with increase in molar mass of amines due to increase in size of the hydrophobic alkyl part. Higher amines are essentially insoluble in water. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. This intermolecular association is more in primary amines than in secondary amines, as there are two hydrogen atoms available for hydrogen bond formation in it. Tertiary amines do not have intermolecular association due to the absence of hydrogen atom available for hydrogen bond formation. Therefore, the order of boiling points of isomeric amines is in the order primary greater than secondary greater than tertiary amines. To summarize this discussion, let us recall the points discussed. Nitro compounds, cyanides and amides upon reduction form primary amines. Ammonolysis of alkyl halides gives a mixture of aliphatic primary, secondary, tertiary amines and quaternary ammonium salts. Gabriel thalamide synthesis is very useful for preparing aliphatic primary amines but not aromatic amines. Boiling points of amines are less than those of alcohols and carboxylic acids of comparable molecular masses. Amines dissolve in water due to the intermolecular hydrogen bonding. Aromatic amines do not dissolve in water. Before we end this discussion, let me leave you with some reasoning-based questions. You are supposed to give reasons for the following statements as shown on the screen. Amines are less acidic than alcohols of comparable molecular masses. Primary amines have higher boiling point than tertiary amines. Aromatic primary amines cannot be prepared by Gabriel thalamide synthesis. Gabriel thalamide synthesis is preferred for synthesizing primary amines. Ethylamine is soluble in water, whereas aniline is not. I hope you understood all the concepts discussed in this discussion. Hoping to meet you again. Till then, take care.